This thing has been on our radar only for about a few months since then. According to astronomers, 3i Atlas has all kinds of surprises.
The rules of the universe just broke down, and it's only 6 miles wide, and now it's doing the impossible, deflecting the solar wind like a planet. It's 3i Atlas, a 6-mile wide mystery that's rewriting the laws of physics in real time. So what is it? A relic of deep space, or something far more engineered? In this video, we uncover the evidence, the theories, and why scientists say this changes everything we thought we knew about space. The arrival of a stranger. On July 1st, 2025, 3i Atlas crossed into our solar system near Jupiter and Mars. Just the third interstellar object ever detected, it's pushing astronomers to rethink what's possible. Atlas moves faster than most comets, clocked at over 137,000 miles per hour. That's nearly twice as fast as previous visitors. It's huge, too, somewhere between 6 to 12 miles wide. But size and speed weren't what raised eyebrows. It was the path it took. Instead of drifting in gently, like a typical comet, Atlas charged in from a strange angle, almost like it had fallen out of the sky. This angle suggested it came from a faraway part of the galaxy known as the thick disk, a less crowded region above the usual galactic plane. The thick disk is different. It's full of older stars and leftover cosmic dust. Not much happens there. It's quiet, cold, and old. So if Atlas really came from there, it may have been on a journey through space for billions of years, maybe longer than our own sun has existed. This makes Atlas the oldest interstellar object we've ever tracked. And that raises even more questions. What's kept it together after so long? What's it made of? And maybe most mysterious, why now? Was it chance that brought it here, or something else? For now, astronomers are just watching. Telescopes are turned, probes are tracking. Every signal, shimmer, change is being recorded. Because in the silence of space, objects don't usually surprise us. But Atlas isn't playing by the usual rules. A magnetic anomaly. On a quiet morning in August 2025, something strange rippled through the solar wind. A wave, barely noticeable at first, stretched across space. It didn't make a sound, but it shook everything. At 8 a.m. UTC, the Solar and Heliospheric Observatory, known as SORAL, picked up a faint arc bending like a wave through charged solar particles. Just 2 minutes later, the Parker Solar Probe confirmed it, and far off, circling Mars, MAVEN recorded it too. 3 separate spacecraft, 1 disturbance. The solar wind isn't gentle. It's a constant storm of particles from the sun, flowing out across the system. It takes something big, like a planet, to change its path. So, when a ripple appeared near 3i Atlas, scientists were puzzled. It didn't make sense. What could a comet, barely 6 miles wide, possibly do to solar wind? But the data wasn't lying. Atlas was acting like a massive magnet, bending the solar wind around it, not just pushing particles away, but changing the flow. That's something we only see with planets that have strong magnetic fields, like Earth or Jupiter. This isn't normal comet behavior. It's not just about the push, it's about the structure. Atlas created a buffer zone, almost like a magnetic bubble, around itself. Something invisible, but strong enough to shield it from the solar storm. The signals from all 3 spacecraft matched. The shape of the disturbance, timing, and the energy levels. Everything lined up. Atlas wasn't reacting to the solar wind. It was shaping it. This shocked everyone. Comets don't do this. They leave tails. They lose material. They get pushed around. They don't push back. But Atlas was holding its ground like a stone in a river, redirecting the flow. NASA scientists called it a Level 1 event, a confirmed, unexplained phenomenon. That meant it couldn't be dismissed as a glitch, and it couldn't be explained by current science. Defying the solar wind. The solar wind is always moving. It never stops, a silent stream of energy and particles flying out from the sun in every direction. It shapes space. It wears down planets. It carves the surfaces of moons. Earth is safe because it has a magnetic field. Think of it like a force field. The solar wind hits it, splits apart, and moves around. It keeps our atmosphere from being blown away. Without it, life couldn't survive. Now imagine a comet. No force field, just ice, dust, and gas. When the solar wind hits, it usually tears off material from the surface, forming a long tail that points away from the sun. That's how we usually spot comets, from their glowing trails. But 3I Atlas isn't playing that game. Atlas holds firm. The solar wind hits and bounces, not fully, but enough to make scientists rethink everything. Not completely, but enough to form what appears to be a shock wave. That's something we expect around planets like Saturn, not a small object flying through space. Even more surprising, the shock zone isn't random. It's shaped, controlled. Like there's something inside Atlas adjusting to the wind, not breaking apart under pressure, but adjusting to it. And it gets stranger. Instruments aboard the Parker Solar Probe picked up high-frequency pulses coming from the area around Atlas. These weren't random noise. They repeated. Clean patterns. Too structured to be natural interference and quite strong to be background radiation. What does that mean? It could mean that Atlas isn't just reacting to the solar wind passively. It could be responding, not with light or movement, but with energy. But the way it holds its shape under that much pressure tells scientists one thing. Atlas is built different, literally. Maybe it's made of stronger materials. Maybe it has some kind of internal structure that regulates magnetic fields. Or maybe, just maybe, it's something we've never seen before. For now, the only thing certain is this. Atlas is rewriting the rules. Every model, every textbook, every assumption about small bodies in space, that solar wind always wins, that small objects don't fight back, is being re-examined. Because out there, in the middle of the solar wind, 3I Atlas is standing still. The anti-tail and the beacon. Most comets grow tails that follow the rules of space. As they near the sun, heat turns their icy surfaces into vapor and dust. The solar wind grabs these particles, stretching them out behind the comet in a glowing streak pointing away from the sun. But 3I Atlas flipped that script. In August 2025, telescopes caught something odd, a second tail, but not where it should be. This one wasn't trailing behind. It was pointing toward the sun, an anti-tail. At first, some thought it was just an optical illusion, but that idea didn't hold up. More detailed images from the Gemini South Observatory and the Webb telescope confirmed it. The anti-tail was real, and it was huge, over 56,000 kilometers long. So how does a comet grow a tail that defies the sun's pressure? The answer lies in the material. Most comet tails are made of fine dust and light gases. But Atlas was throwing out much heavier grains, chunks of ice and particles too massive for sunlight to push around. These heavy grains didn't drift away. They clung close to the comet's path, forming a line that stretched toward the light instead of away from it. Like a ship dragging a spotlight behind it in the wrong direction. Some scientists describe it like this. If the main tail is a comet's whisper, then the anti-tail is its echo. And in this case, it's an echo of something powerful happening on the sunlit side of Atlas. That's not the only thing that stood out. Spectrographs showed something unusual in the glow around the comet. The gases weren't what we usually see. There was far more carbon dioxide than expected, very little water vapor, and just a small trace of carbon monoxide. This isn't normal for comets. It means that Atlas is not only ejecting material differently, it's made differently too. Whatever is under the surface, it's reacting to sunlight in strange ways, releasing gases in patterns that look more designed than random. Some researchers started comparing the anti-tail to a beacon, not in the sense of a signal, but as a kind of trail marker, a visible sign that something is traveling through space with intention. Think of a flashlight shining through fog. The light isn't the message. The way it spreads is. Atlas's anti-tail may be working the same way, revealing more about the object by how it interacts with its surroundings. The more we look at Atlas, the more it feels like it's telling a story, not in words, but in patterns. A pattern of resistance, a pattern of structure, movement that isn't random. Atlas resists a solar attack. In late September 2025, the sun flared up. A coronal mass ejection, a CME, burst from its surface. It was big, fast, and heading straight for 3I Atlas. CMEs are storms of plasma and magnetic fields that shoot through space. When they hit a planet or a comet, they can do serious damage. Satellites go offline, magnetic fields wobble, tails vanish. It's happened before. In 2007, a CME slammed into Comet Encke. Its tail was ripped off like a kite caught in a hurricane. Just like that, gone. So when scientists saw this new CME racing toward Atlas, they braced themselves. Everyone wanted to know, what would happen this time? Atlas was already unusual. It was bigger than expected, moving faster, giving off strange energy signals. Now it was facing its first big test. And then, nothing dramatic happened. The CME hit. But instead of tearing Atlas apart, the object stayed steady. Its tail shimmered, shifted, then settled back in place. It didn't break, it didn't slow down. Instead, it seemed to flex, just slightly, then keep moving. What the probe saw was strange. The tail of Atlas didn't vanish. It reformed, quickly, like it had snapped back into shape. That caught scientists off guard. If Atlas were a regular comet, its structure should have been disrupted. But here, it acted almost like it was built to handle it. Even more interesting was how clean the reformation looked, and that raised more questions. Is Atlas covered in some kind of protective layer? Is its material stronger than ice and dust? Could it even be adjusting itself mid-flight? Some even wondered if the CME had been a trigger, like pressing a button. Because after the collision, readings from nearby instruments picked up increased outgassing and higher temperatures. It was like Atlas came alive in response. This wasn't defense. It looked more like adaptation. Whatever Atlas is, it's not just surviving space. It's interacting with it. Not like a rock, more like a probe, a system, a mechanism built for exploration or something else. There are still no answers, just signals, reactions, and patterns. But the CME didn't destroy the mystery, it only deepened it. Signs of the unnatural. In the weeks after the solar storm, more instruments began locking onto 3I Atlas, and the data they returned didn't match anything in the known playbook. One of the first surprises came from the Sphere-X space telescope. It showed that Atlas was releasing more carbon dioxide than expected, far more than water or even carbon monoxide. That's not what we see with comets. Water is usually dominant. Here, it barely showed up. Then came the nickel. A sharp chemical signature picked up by the Very Large Telescope in Chile showed Atlas had large amounts of nickel, but no iron. That's unheard of. In space, nickel and iron are always found together. They're twins from the same supernova birth. You don't get one without the other, unless something separates them. And on Earth, the only thing that does that is industrial smelting, man-made processes, which sparked an unsettling thought. What if Atlas isn't a random space rock at all? What if it's built? Astronomers aren't jumping to conclusions. They know better. But the evidence is stacking up. Heavy anti-tail, magnetic shielding, clean nickel without iron, strange energy patterns. It's not one oddity, it's a collection. Then there's the shape. Atlas's movement is clean, smooth, not chaotic like most tumbling space ice. Some astronomers noticed that it aligns too neatly with the ecliptic, the flat plane where all planets orbit. It's flying as if it's meant to be seen or studied. The questions keep coming. Could it have passed through something long ago? A place in space where its materials were changed? One theory suggests it traveled through a supernova's magnetic wake, soaking up energy like a sponge. But that still doesn't explain the precision. Others wonder, is it sending something back? Could Atlas be a delivery system, a slow-moving explorer designed to cross galaxies and collect data? Nothing confirms this, but nothing rules it out. Atlas is acting with purpose. Whether nature or design gave it that purpose is the mystery. It doesn't look broken. It doesn't look ancient and falling apart. It looks deliberate. And in the vast stillness of space, deliberate things are rare. So the scientists keep watching, measuring, waiting. Because the truth about Atlas might not come from its tail, or its speed, or its shape. It might come from what happens next. A theory from the stars. A few researchers believe the answer might not be in the object itself, but in the space it traversed. One theory gaining attention came out of MIT. It suggests Atlas may have passed through the magnetic remnants of a long-dead star, a supernova. When a supernova explodes, it sends out shock waves. These waves carry not just energy, but magnetic fields, fields strong enough to leave a mark. If Atlas drifted through one of these zones during its ancient voyage, it may have soaked up that magnetism, slowly, over millions of years. It's a bold idea, but it could explain the magnetic shielding. It might also account for Atlas's calm reaction to the solar wind and even the CME, like a sponge filled with the energy of a dead star. But there's another layer to this. If Atlas did come through a supernova zone, it would carry a signature, a trace of that star's last breath. And some of the gas samples around Atlas, they do show hints of rare elements that line up with what we see in supernova dust. That alone is fascinating, but not enough. Other scientists are going further. Some say the structure, the behavior, and the resistance to space's harshest forces suggest Atlas wasn't just changed by the galaxy. It was built to survive it. That opens the door to something much larger. Harvard astrophysicist Avi Loeb is among those asking the big questions. He's not saying Atlas is artificial, but he's not ruling it out either. His thinking, if we send probes into space, why wouldn't someone or something out there do the same? Atlas could be just that. A vessel designed not to send signals, but to last, to drift, to endure until it's seen. It might not need to do anything flashy. It could be testing our reactions, studying how we observe, even recording how we respond. Some call that science fiction. Others say it's just good science. Ask questions, test assumptions, explore possibilities. Because everything Atlas is doing so far, it fits none of our models. But it's not random either. The trajectory is precise. The material is resilient. The behavior is too structured to ignore. If Atlas came from deep space on purpose, that changes how we think about the universe. It means we aren't just surrounded by stars and dust. We're in a galaxy where curiosity might not be unique to us. Echoes of Oumuamua and Borisov. Atlas isn't the first visitor from beyond the stars. In 2017, we spotted Oumuamua, a long, thin object moving too fast to be from our solar system. It came and went quickly. No tail, no gas, but somehow it sped up as it left the sun. That shouldn't have happened. Scientists scratched their heads. Some said it might be a solar sail. Others thought it was a strange kind of comet, venting invisible gas. 2 years later, in 2019, we found another, 2I Borisov. This one looked more familiar. It had a tail, it vented gas, but its chemical mix was different, rich in carbon monoxide, possibly from the outer rim of a far colder star system. It was small, just a mile across, and passed by quietly. Now we have Atlas, and it's not like either of them. It's larger, more massive, and filled with more contradictions. It's releasing gas, yes, but not the usual kind. Its magnetic behavior doesn't match anything we've seen. And its anti-tail? That's new. Where Oumuamua gave us a mystery of motion and Borisov offered a taste of alien chemistry, Atlas gives us something bigger. A challenge to our understanding of how small objects behave under pressure. There's also a sense of evolution here. Each interstellar visitor has been weirder than the last. Oumuamua was silent and fast. Borisov was cold and volatile. And Atlas? Atlas is resilient. It interacts. It endures. And it may be the first of these objects that seems to push back against its environment instead of being shaped by it. Some astronomers wonder, are we seeing different classes of interstellar objects? Different ages? Different missions? Because if we've spotted 3 of these objects in less than a decade, maybe they're not so rare after all. Maybe we just weren't looking hard enough. Thanks to new observatories, like the Vera Rubin telescope, we're now able to catch these faint, fast-moving travelers more often. And that changes everything. It means we're no longer alone in our corner of space. Other systems send pieces of themselves through the void, sometimes by chance, sometimes, maybe, not. Atlas isn't just a sequel to Oumuamua and Borisov. It's a new chapter in a growing story. One that says interstellar space is more connected, more active, and more mysterious than we ever thought. And this time, we're here to witness it in real time. The Atlas question. As Atlas moves deeper into the solar system, it's reaching a critical point in its journey, perihelion, the closest it will get to the sun. This is where most comets begin to fall apart. They heat up, they break down, some vanish entirely. So what will happen to Atlas? This moment, October 29th, 2025, is what astronomers call a stress test. The sunlight will be stronger, the solar wind will hit harder, radiation will spike, and if Atlas is hiding anything beneath its surface, this is when it might finally be exposed. Until now, it's kept most of its secrets. It hasn't crumbled. It hasn't changed direction. It's just kept going, steady and strange. But as the heat rises, scientists are watching for cracks, flares, or changes in its magnetic field. Even a flicker of light or a shift in spin could give away something we've missed. The key question isn't whether Atlas will survive. It's how it survives. If it breaks apart, maybe we'll finally see what's inside. If it stays intact, that might be an even bigger clue. Because nothing this small should handle solar heat and wind without showing stress. So far, Atlas has shown control. That's what's really strange. It doesn't just react, it adapts. And that's what's bothering researchers. It feels intentional. Even more, it seems like Atlas is aware of its surroundings, not in the conscious sense, but in the way it adjusts its outgassing, shapes its tail, and stabilizes under pressure. That's not normal. That's engineering. Some scientists say it's time to move past the old assumptions. Maybe the real question isn't what Atlas is made of or where it came from. Maybe the real question is, what was it made for? It might be natural, shaped by forces we don't yet understand. Either way, Atlas is putting pressure on modern science to rethink its rules. For centuries, we've believed that small means fragile, that only large bodies like planets can fight the sun's fury. Atlas just proved otherwise. And now, everyone's watching. Every observatory, every solar probe, all waiting for the moment the comet either speaks or shatters. Rethinking the universe. Science is built on certainty. Equations, predictions, models. We trust them because they work. But sometimes, something drifts across the sky that doesn't follow the rules. 3I Atlas is one of those things. A small, icy object from deep space wasn't supposed to survive this long, or move this way, or resist the sun's fury. It wasn't supposed to have a magnetic shield. It wasn't supposed to produce strange chemical trails. It wasn't supposed to exist. And yet, here it is. Atlas didn't arrive with flashing lights or answers. It came quietly, just questions. But those questions cut deep. They challenge our understanding of physics, of chemistry, even of time. How does something this small bend solar wind? Why does it hold a structure like engineered metal? Why does it move like it has a plan? It doesn't take aliens or sci-fi to feel the weight of this. Just observation, just evidence. Atlas is a reminder that the universe still holds unknowns, real ones. Not just gaps in our knowledge, but walls we didn't even know were there. So now, scientists are doing what they do best, not jumping to conclusions or making assumptions. They're taking notes, building models, forming new theories. Some are reworking the very idea of magnetism in interstellar objects. Others are diving into exotic chemistry, elements formed in the first stars, particles shaped by ancient explosions. Some are even wondering if Atlas is a traveler not just through space, but through time. Because if this object really is billions of years older than our solar system, then it's a messenger from a different era of the cosmos, a witness to things we've never imagined. And if it's artificial, even in part, if it was built or shaped by intelligence, that means we're not the only curious ones out here. The universe may not be quiet. It may just be complex. Atlas might be a product of random cosmic chaos, or it might be the first trace of something bigger. Either way, its visit is forcing us to redraw the map of what's possible. We used to think space was empty, that the silence between stars was simple. Atlas says otherwise. It says the silence is full of meaning. So whether it burns up, breaks apart, or sails on, we'll remember Atlas not for what it told us directly, but for what it forced us to ask. If you enjoyed this journey through the unknown, hit that like button, subscribe, and turn on notifications so you don't miss the next cosmic mystery.